Hey guys, in this lesson we would understand the application problems of similar triangles. Let's read the first question. The tips of the shadows of a tree and of a meter stick meet at the point X. So we are given this is the tree and this is the meter stick. Shadow is always made on the ground. So tip of the shadow of the tree is formed at X, as well as the tip of the shadow of the meter stick is also formed at X. That's what it means when it says meet at the point X. We are also given XS, that is this length, to be 3.5 meters. And we are given this length ES, 6.5 meters. We have to use this information to find the height of the tree. So we are supposed to find out this height. Now because this is given to us as a meter stick means this size or this height is given to us as 1 meter. Now, how do we know this problem is a similar triangle problem? Is because we are given information for two separate triangles. If we make these two triangles separately, this is how the two triangles would look like. This is the tree, this is the shadow of the tree. So we can mark it as TEX triangle and this triangle. So this is the bigger triangle and this triangle is a smaller triangle, that is MSX. Now for one triangle, we are given full side length XS as 3.5 meters and MS as 1 meter. The other triangle, we are given ES as 6.5, and since the big triangle base is going to be sum of ES plus SX. That's how we get EX. So this is ES plus SX. ES is 6.5 and SX is 3.5. That is equal to 10 meters. So this whole length is 10 meters and this is the height that we are looking for. Now we notice that both of these triangles, they look alike. So if we are able to prove them similar, then we can use the properties of similar triangles, that is the scale factor of the side lengths, in order to find out the unknown side length. That's what we are looking for. That's how similar triangles is useful in this particular example. So the first step is to prove the two triangles similar, because if the triangles are proved similar, then only we can use the scale factor to find this height. Now the process to prove the two triangles similar is that if we are able to prove their two angles are equal, then the triangles become similar triangles. So we will be taking up in triangle TEX and triangle MSX, angle E is equal to angle S because this thing is given to us as 90 degree. Therefore, these two angles are equal. Then we notice that angle X and angle X are equal because they are the angles formed at the same point, because this is common to both the small triangle as well as the big triangle. So definitely this angle is going to be same for both. So how do we write it down is, we should not write down X is equal to X. We should in fact write down the full name of the angle, that is angle TXE is equal to angle MXS. And why do we need to write down the full name of the angle? So that it can be shown that this X angle belongs to one triangle and this X angle belongs to the other triangle. However, since both the triangles lie overlapping to each other, that's why this X becomes common. So that's why we have to write down is equal to common. Now whenever in two triangles, two angles are equal, third angle becomes equal automatically because of angle sum property of triangles. And angle sum property of triangles is expected to know from the lower grades, that is the sum total of all the angles of a triangle is 180 degrees. So this third angle would be equal to 180 minus the sum of the other two angles. So if these two angles are same, their sum is also going to be same. And when they're subtracted from 180 degrees, these angles would become equal. So we can write down here angle T is equal to angle M because of angle sum property of triangles. Now once we have proved the three angles equal, we can finally write down triangle TEX is similar to triangle MSX. So this is our step 1 done. Next is step 2. Because now the triangles are similar, so we can find out the scale factor using the corresponding sides of the triangles. Therefore, step 2 is determine the scale factor of the given triangle. And how do we do that in this particular example? To find out the scale factor, we have to write down the corresponding sides of the two triangles as a common ratio. Now, since we know the two triangles are similar, their corresponding sides ratios would be equal. Therefore, we can write down EX over SX is equal to TE over MS, that's here, is equal to TX over MX, and that's here. Now, to determine the scale factor, we use any one side ratio where we are given both the side lengths of the triangle. So we notice that EX side length and SX side length is known to us. EX is given to us as 10 and SX is given to us as 3.5. So this is going to be called the scale factor of this question because the ratio of the corresponding sides is equal to the scale factor. We can put this on the calculator and turn it to decimals, or we can just leave it as fraction. So the scale factor, that is the K value for this particular problem, is 10 over 3.5. Next we have is the step number 3, and step 3 says use the scale factor to determine the unknown side length. And how do we do that in this example is the unknown side length that we have is TE. That along with MS we can write as a ratio equal to the scale factor that we have found in step 2. So we would write down TE over MS is equal to 10 over 3.5. TE is nothing but the height of the tree. We can substitute it as H, and MS is nothing but a meter stick, so length of this is 1 meter. Therefore, we would write down H over 1 is equal to 10 over 3.5. All we have to do is just cross multiply. So we would get H equal to 10 over 3.5 times 1, and that is equal to 10 over 3.5, which is equal to 2.857 meters. Since we're asked to round the answer to the nearest tenth, we would round it to 1 decimal place. So the final answer is that the height of the tree is 2.9 meters. And that's the answer to the question. Let's take up another example for the sake of practice. The second question is, use the dimensions of the surveyor's triangles to find the width of the river to the nearest meter. We know this is what is made with blue color is the river, and width of the river is from this end to this end. So let's mark this width of the river as X. These angles, or these two triangles, have been made by the surveyor who wants to find the width of the river, because it's not possible for the surveyor to actually measure the width of the river. So that's why similar triangles are used. Now we can see there are two triangles. One is this triangle and the other is this small triangle. Just to make it easier, we'll draw the two triangles separately, and let's name the triangles as well. Let's call this A, B, C, D, E. The first triangle is this ABC triangle, where 90-degree angle is marked at angle A. And the second triangle we have is triangle CDE, where 90-degree angle is formed at angle D. Now, we are given side length CD as 17 meters, side length ED as 15 meters, side length AC is given to us as 50 meters. Because AB is the side length that is exactly parallel to the width of the river, so if we find out the side length AB and mark it as X, we would be able to get the width of the river. Now, whenever we are given two triangles, and we have to find out the unknown side length when we're given dimensions of one of the triangles, then we know we have to use the properties of similar triangles. However, in order to use the properties of similar triangles, we first have to prove the two triangles similar, and that is step 1. So the two triangles we have is in triangle ABC and triangle CDE. We know angle A is angle D, and that is equal to 90 degree. So these two angles are equal. Because these two triangles have come from here, so we notice here that angle C is common for both the triangles ABC and CDE. Apart from just being common, these two angles that lie in two separate triangles are forming vertically opposite angles. angles. So we also know that vertically opposite angles are always equal. Therefore, we would write down angle ACB, that is ACB, so this is this angle, is equal to angle ECD, that is this angle. And they are equal because they are vertically opposite angles. Whenever we are proving angles equal, we also have to write down the reason behind those angles to be equal. As we know, the two angles of these two triangles have been proved equal, so third angle is automatically going to be equal. That is angle B and angle E because of angle sum property of triangles. And once the three angles are proved equal, the two triangles are proved to be similar. Since the triangles are similar, now when we've got the two triangles similar, we can write down the ratio of the corresponding sides to be equal. Now let's first look for corresponding sides. AB and ED are corresponding because AB and ED, both the side lengths, lie between the angle 90 degree and this dot marked or circle marked angle. Therefore, second step is AB over ED equal to AC over CD because both AC and CD are the side lengths lying between 90 degree and single line marked angle. That is equal to BC over CE. Out of these three ratios, we can use AC over CD to find out the scale factor because both of these side lengths are known. So we would be using AC over CD where AC is 50, CD is 17 to find the scale factor K. We can leave it as a fraction and now we would be using the scale factor to put it equal to the ratio that contains our unknown side, and unknown side is AB, that is this one. So we would be putting the scale factor equal to this ratio. That's step number 3. AB we know is X. ED is 15 equal to K is the scale factor and that is 50 over 17. In order to find out the value of X, we would isolate X. So we have 50 divided by 17 times 15. And that is equal to 44.11 meters. The question wants us to find the answer to the nearest meter, that means to the nearest whole number. Therefore, the width of the river is equal to 44 meters. And that's the answer to the question.